pie graphs, what they're used for and how we make them. Throughout this unit, I'm not too concerned with drawing it down to the degree or with 100% accuracy, only because there's so much software out there nowadays that makes a circle for us, but they don't make the data for us. So we have to understand what the numbers represent to know if the computer program's giving us the right answer. So what are pie graphs used for? To compare parts of a whole. And yes, this is your note you need to be writing down. So when we compare parts of a whole, we could compare our whole class with something. We couldn't compare our class and a grade 8 class. That's what a bar graph's for. Or we could compare the whole school. We have to use one whole piece of something. The circle represents 100% or one whole. And remember that fractions, say 25 over 25, is also equal to one whole. And that we need to be able to do fractions to decimals to percents and the other way around. So let's do a quick review of how we look at fractions, decimals, and percents and what they mean to us. So let's start with 13 over 20. How would you find out the decimal or percent? Any ideas? Pause it here and let them share their ideas. So what I'm hoping is that you recognize that 20 was a multiple of 100, and you could have used your common denominators. We could have said times 5 and times 5 is 65, and that's a lot easier to get our decimal. So we have 65 divided by, remember this bar for our fractions is an operation, it means division. So you have on your calculator decimal 65. And how we get that to a percent? We times by 100, and you have 65%. Now, although you have your calculators and you're allowed to use them, you shouldn't have to write this times 100 on your calculator. When you get this decimal on your calculator, you know that when you're multiplying by 100, it's 2 zeros, so you're just moving the decimal place. So this is 65%. Okay, we don't usually write the decimal at the end, but we can. So anything that's a 2, 5, 10, 20, 25, those are all nice divisors of 100. They work evenly. Oh, we forgot 4. And you can find common numbers to get to 100. Or we could just use the calculator and you could divide 13 divided by 20 and you're going to get that. You just need to be able to recognize that sometimes mental math is quicker than a calculator. But what happens when it's not one of these pretty numbers? What happens when it is, let's just call it an ugly fraction? Let's look at an ugly fraction. On your calculator, what does 7 over 15 say? 0.46 repeated. Now I'm going to write a few of them out. 0.466 repeated. We multiply by 100. 1, 2. And now we have 46.66%. If you picture your circle, can you draw 0.66% accurately on your circle? Probably not. So what we can do, the common question always is, how many decimals do I need? Well, what you need is you need this third number to know to round to the ones. So we want to always round our percents to the ones. Now if we're using a computer program, we can leave the decimals, it'll be able to do it. But for us in our approximation right now, this is 47%. Now, some of us are still doing these calculations by hand, which is fine, but we need to, one, understand what is a remainder, because remainders are just a numerator. They're not a decimal. And how would we set this up using long division? So I want you to write this down as well, but we have to go 15 into 7. Well, can 15 go into 7? No. So as soon as you say no, you know you need a 0. And let's put another placeholder here. So can 15 go into 7? Or sorry, 15 go into 7D? Well, it can go in 4 times. 4 times 15 is 60. Now we subtract. Can 15 go into 10? No. So again, I said no, so I'm going to put a 0. And I'm going to bring it down. Can 15 go into 100? Yes, it can. 6 times. 6 times 15 is 90. I'm going to subtract it. It's a 10. Can it go in? 15 go into 10? Nope. So that means another 0. And this is how we don't use remainders, but we now have placeholders and gives us our repeating decimal. So now we have our 6 again. Okay, so if you're using your long division, that's fine, but you just need to understand which order they go in and when to use our placeholders. It's your turn. So now, take this practice, and we're going to do a set of data. So let's say you survey a school, and sorry, cheat here. Okay, so, and you survey what their favorite subject is. So 14 people voted math, 27 people voted science, 36 people voted recess, and 5 people voted gym. Give me the fractions, the decimal, and the percent. And then sketch the circle, which means it doesn't have to be perfect, but it should be obvious of there should be 4 sections and which section is larger than the other. So sketch your pie graph. And so that's 1, 2, 3, 4. Your 5th component, how do you know you're correct? How can you justify? And your response cannot be because I checked my calculations or because I used the calculator. How do you know you're correct? Okay, so you're now working on these 4 steps. Sorry, 5 steps. And my prompting question to you is, what is your denominator? Hint, you might need some addition. If there's time, take them up on the document camera. If not, we'll take them up next class.